Good morning, children. In today's class, we are going to learn some special integrals. Last year, we had learnt a square x square combination in the denominator with square root, without square root. So this year, we are doing some special problems. Say, sine square, cos square combination in the denominator. How are we to do it? Let us see some examples. Exercise 9.5. Evaluate integral 0 to pi by 2 dx by 1 plus 5 cos square x. The numerator and denominator, we are going to divide by cos square x. This is a technique that we should remember in such models. Dx by cos square, 1 by cos square, 5 cos square by cos square. 1 by cos square, I can write secant square x. Denominator also 1 by cos square is secant square. Here cos square cancels. Whenever I have secant square x dx, tan x will be the substitution. So put t equals tan x. When I change, I have to differentiate. T becomes dt, tan x becomes secant square x dx. To change the limits are from 0 to pi by 2 for x. For t, when x is 0, t is equal to tan 0. Tan 0 is 0. When x is pi by 2, t equals tan pi by 2, that is infinity. So the limits will now become 0 to infinity. To substitute tan x, this numerator secant square x dx, I can write dt. What about the denominator? This secant square, let me rewrite using the identity 1 plus tan square x. 1 plus 5 becomes 6. Tan square x becomes t square. Now I recall this format. A square plus x square combination in the denominator. So integral dx by a square plus x square. Let us recall the formula 1 by a tan inverse x by a. Comparing the formula in the given question. 6 is written as root 6 square. So a is root 6, x is t. Applying the formula, I is 1 by a tan inverse x by a between the limits 0 to infinity. 1 by root 6 into tan inverse. Infinity by root 6 is infinity. Minus tan inverse 0 by root 6 is 0. So wherever t comes, we put upper limit infinity and lower limit 0. Upper limit minus lower limit. 1 by root 6 into tan inverse infinity. Tan 90 is infinity, so this gives me pi by 2. Tan inverse 0 is 0. So together I equals pi by 2 into root 6, and that is the answer. Second subdivision, integral 0 to pi by 2 dx by 5 plus 4 sine square x. As I see sine square x, we learnt a little before with cos square. So rewrite sine square as 1 minus cos square. 4 into 1, 4. 4 into cos square, 4 cos square. Add these two, which gives me 9. Now it becomes the pattern as the previous problem. Divide by cos square x every term in the integral. As I divide, dx by cos square x becomes secant square x dx. 9 by cos square becomes 9 secant square. 4 cos square by cos square cancels. I am getting 4. As before, put t equals tan x. Differentiate. T becomes dt. Tan x becomes secant square x dx. Changing the limits. X limits are 0 to pi by 2. When x is 0, t is equal to tan 0, that is 0. When x is pi by 2, t equals tan pi by 2, that is infinity. My question is rewritten as integral 0 to infinity. Secant square x dx is dt in the numerator. Denominator secant square we rewrite as 1 plus tan square x. 9 into 1, 9, 9 minus 4, 5. 9 into tan square becomes 9 into t square. 5 can be written as root 5 square. 9t square can be written as 3t the whole square. Compare it with the formula integral 0 to infinity 1 by a square plus x square dx. A little before we did integral 0 to infinity 1 by a square plus x square dx is 1 by a tan inverse x by a between the limits 0 to infinity. That is 1 by a tan inverse infinity gives me pi by 2. Tan inverse 0 gives me 0. So what is my answer? Pi by 2a. If the limits are 0 to infinity, for one word problems, it is good that we remember the answer pi by 2a. Or else, you apply in the formula and then apply upper limit, lower limit and then arrive at the answer. In this problem, a is root 5 and in the place of x, I have 3t. So, substituting this formula, that is pi by 2a. Pi by 2 into a is root 5. This formula applicable if it is only x. If it is 2x the whole square, you must divide by 2. Here I have 3t the whole square. So after applying the formula, for 3t I will put 1 by 3, simplify and write the answer. If you are not applying pi by 2a, we shall do it directly. Integral 0 to infinity dt by root 5 square plus 3t square is, as I apply the formula, 1 by root 5 tan inverse 3t by root 5. Once I complete, whenever 3t is coming in integration, remember to put 1 by 3. Apply the limit 0 to infinity. That is 1 by 3 root 5 into tan inverse infinity minus tan inverse 0. That is 1 by 3 root 5 into tan inverse infinity is pi by 2, tan inverse 0 is 0. Or I get pi by 6 root 5. Both are one and the same. Either you write directly pi by 2a into 1 by 3. Or you apply the limits and simplify as usual.